Cool. So thank you so much, everyone, for coming. My name is Tom. I graduated in 2020, so 2 years ago during the pandemic from the department. So both nostalgic and traumatic to come back here. So well done for finishing our exams. Hand on the shoulder. This is why there's the Prosecco reception. Regarding today's talk, so it's going to be a pretty short presentation from my side, 15 minutes long around there, and then it's going to be like an open floor Q&A for around 10 minutes. And then we've got the Seamless people at the back, so we can network and feel free to eat more. Apparently there's more pizzas coming in. Fantastic. And yeah, so let's make a start. So imagine you got £500,000 and you are told to spend it all in the most complicated way possible. How would you do it? Right, first you purchase some data set. You get your purchase data set, you hold something out just for back testing. You set up your research pipeline, your modeling pipeline. And then you set up your trading strategy. You employ some PhDs for the quant trading, the quant research, and so on. You hire some amazing software developers, chain them all together, then to think about monitoring, reporting of your execution strategies. And then you think about your operational setup, banking, accounts, etc. Then you're like, okay, this is all good. You turn it down, boom. So this is not exactly a made-up figure. Obviously, I'm trying to not to leak any company information. But let's say for a period of time, 1 month, fantastic. You've spent your 500K completely. So the thing with algorithmic trading is there's many ways things can go wrong. Many ways, and there's only very few ways, and sometimes only one way for things to go correctly. And a lot of times, what we spend is to figure out is to fail, and things go incorrectly, reflect, and then say how do we avoid this mistake? How do we never repeat the same mistakes ever again? So then, what exactly is Seamless? So I've already done my introduction. So we've got Hamish at the back there. Came here for Nesky, went to the other side for PhD, went to MIT for postdoc. We've got Doug, similar story. Charles, similar story. Zhongyi is our Kaggle expert. And we've got Jack, who is on our execution team. So this is the software development plus trading execution. And then we've got David, who's unfortunately in Scotland currently. He's actually the #1 ranked Scottish player, poker player. And then we've got Joe, our old guy at the back. He was in the British Army flying Apache for the Special Forces, then went to Goldman, then came to us. We've got Val, who's unfortunately ill today, and he's our president of the company. Came from the institute at Princeton. And then we've got our founder, who came here for economics and then played poker professionally and then used the poker money to found Seamless. And then what exactly do we do? So we are in sports betting business. So specifically, we trade horse racing. In UK, our position currently is top 2 quite consistently. And that's now a finished product. So now we are tackling the Hong Kong horse racing market. So that's our current position. And it's very important to note that we are not a research firm. We don't do research. I know in the job title, there's quantitative research and so on. We are a profit-driven firm. And sometimes the thing that we do appear to be researchy because you need to find that edge, so that a thing that beats the market that no one knows. That can appear to be researchy, but we are not working to publish papers. That's just a very important distinction. And in terms of our culture, we are brutally honest with each other. And again, just going back, there's so many things that can go wrong. If you're not honest with your own mistakes, with others' potential mistakes, you are setting cash on fire. And the key principle we operate is pain plus reflection equal to progress. As in, we expect things to go wrong. People are expected to make mistakes. It's acceptable to make mistakes. It's not acceptable to not learn from these mistakes. We love our postmortems. When things go wrong, people sit down and collect the dots, write down what's the biggest lesson I've learned from this, what are the key actions I'm going to go from there. And that basically is how the company operates. And that's basically going to be the content of today's talk, where I'll give you guys some case studies on some of the painful failures I have like personally experienced, and what were the lessons and what were the actions that we have drawn from it. So let's go straight in. Case study 1. So we're in the horse racing business, and sometimes you look out for alternative data set, for the new data set. And you see, pedigree. So horses, mother, father, grandfather, whatever, seems like a good potential source of data. So you purchase that data, and it's quite simple. it's like 4 columns. You'd be surprised at how expensive this data set is, because you need to buy them all the way to the, like as early as possible, to the year 2000, 1997, and so on. So you purchase them, you look at them like, okay, reasonable. And then let's make a model. Let's make features, let's make model, let's develop strategies on top. Cool. So then, this is the only technical side, so I'll be showing this plot all the time. And the idea is, imagine if you have a strategy that's got an average return of, let's say, 10% per trade, but the variance is huge. It's okay to have that huge variance if you can do multiple trades. So the way we do it is we do a cumulative sum of your returns over time. Because if you don't do that, your returns is going to look like that. It's like a very nice little white noise process. You can't extract anything from it. So then we do this cumulative sum. You can literally see it as like the sum over time of your portfolio, basically. So, and obviously here, what we care about is a gradient, right? So if your gradient is roughly constant, which, as you can see, roughly is, then fantastic. And also just to bear in mind, if you have no variance whatsoever in your returns, what that means is you should borrow money from the bank, get everyone to like bet on this. You can't lose. So you will naturally have this variance in your average return. So okay, so you can see you have your new model in the light blue sign. You have your old model in the yellow sign. Well, clearly the new model is better than the old model. So bear in mind, this is like months of work. This is 1 month of work from the date where you purchase the data. Clean it, feature engineering, modeling on top, backtest, and so on. Cool, so this looks pretty promising. Now you look at it, you're like, what can go wrong here? So let's see. Let's plot, the display is not that good. So let's plot the difference between the two profit and loss graphs. So you see here in the, can't really show you, steep increase and then suddenly drops at the last 2,000 rows. If you can sort of see the faint underlying color there. So that's the difference.
Tom, there's a big step next to that.
Thank you.
Thank you very much.
Cool. So you see, if you trace this line, it goes up and down. And bear in mind, this is increasing in time. Time increases. And then you're like, okay, when did I turn this strategy on? At around 2000. So what does that mean if you were to plot out your cumulative return for the last 2000 index? It looks like this. And you can measure the p-value on whatever. Bear in mind, all these data set is made up. Can't really share private information. But this is roughly the case that what we saw would be, since we started trading, which is around here, since we started turning this model on, the new model is consistently worse than the old model. So then you go into what I call witch hunting. What exactly can go wrong? Like you start examining your data set, examining your assumptions, what on earth happened. So this is a classic case where it shows great in backtesting, really terrible in live. What happened?
Wait, Tom.
Yes.
So do you mean that for the first 10,000 trades, this was your training data set, but then the last 2,000 was your testing data?
This is your yes. So normally you model on this data set, and then you evaluate on the held out data set. From 0 to 10,000, that's your held out data set. From 10,000 to 12,000, that's your live. So now this is in production now. So this is like real world, basically. You would purchase your data set from, say, minus 100,000 all the way to 10,000 index there. So you purchase data all the way. You hold that part out because you don't want to snoop it too much. So then when you see an increase, you're like, okay, chances are I've actually done something right here to improve the model. Does that answer your question?
Yeah.
Cool. Okay, so you see this case, you start debugging, blah, blah. What actually happened is this. So your data provider provides you the historical data set. And then your data provider also provides you the live data set, right? So when you ask, well, whose horse's mother is today's horse that's racing today, and they will give you like a value. That's all quite legit. And then you have your race result. And the data provider would then go back to the historical data set and adjust certain values. And turned out this data provider provides NaN values more frequently for the horses that lose. In a sense that he's like, horses lose frequently. I'm not going to be bothered to get its pedigree data set, who are his father, mother. If the horse has been winning more often, okay, I'm going to go back and backfill these NaN values to something that's actually meaningful. So in this case, a single feature of is it NaN, is this value empty, would actually be meaningful to whether the horse wins or not. But obviously, this behavior is not mimicked in the live data set when the data provider serves you, because the data provider basically just goes, I don't know, NaN, not NaN, it's random. But in your backtester, the data provider fills NaNs more often when the horse wins. And that's what we call leakage. And it's like very bad news. Because what I'm seeing here is 1 month work to get there, 1 month work to debug, and you're left with nothing. You're left with, let's ditch this entire data set. This is not a reliable source. So that's called 2 month work just completely wasted. And fortunately, for us, we put things into shadow trading mode, where we monitor performance. If you were to turn on trading at 10,000, and if you were to actually trade, you are just losing profit from the right side graph. So then, in terms of lesson, you want to set up the fastest feedback loop possible. You want to spot the hours in days, not months. For example, we should have just, as soon as we see any slight improvement, it shouldn't be that large, just any slight improvement, you turn it down. You turn it down into shadow trading mode. You collect your data straight away. You try to spot problems straight away. It's the live performance actually as expected. You want to do that as soon as possible. You don't want to model continuously for a month and be like, oh, I've added like 15% return to our portfolio. Fantastic. Let's then turn it on, because then you're wasting your time. You spend like a month debugging the problem. Then concrete action, set up automated data checks for leakage, deploy in shadow mode constantly, minimum viable product, not all at once, shorten model improvement to deployment feedback loop. And these are the sort of principles that we do operate on. So currently from our side, going from an idea that shows any marginal improvement on the held out data set to deployment automatic, what we call quality assurance check, 24 hours, basically. 24 hours, 48 hours. So case study 2. So currently, so imagine this is what you show to your manager or something. Be like, this is my portfolio. Okay, so it's returned 50K in the past, let's say 1 month. And then your manager goes, what? This is crap. Because I thought you were going to say this is going to return me like 100K or something. That's from your back tester. You said it's 100K. Like, why is it only 50K for the past month? And then say, okay, let me plot it out again. It's quite interesting. It's like, okay, so on the yellow part, that's what you see on the left side. It's the same data set. I know because of the scale, the axis, it doesn't look that similar, but trust me, it's the same data set. Okay, so then you say, well, clearly it's been pretty bad, so what could be the problem? Data issue, model issue, market drift, market efficiency increases, COVID could be the problem. You never know, because in your backtesting, it's never seen COVID. And then, so I did this work actually personally. Is so we've seen this sort of thing before, where like we go on like this witch hunt, and this 1 month witch hunt. You start going, all right, data issue, let's check data. Model issue, check model. Market drift, check market drift. Efficiency, is COVID the thing? Like you wipe out half a year of your data set. You let your model predict on this half a year gap, and then blah blah blah. You do all this check, and then you sort of like look at all this data, be like, I can't make reasoning out of this. Like, I don't know what's going on. Then someone goes, well, why don't you go back a step? Let's say let's say market gets more efficient, whatever, everything's absorbed into this one simple equation, right? Where your return is modeled by average return minus like this time decay factor. Let's model some decay because other people get more and more efficient and so on. Let's model this factor in. And then let's model what it actually looks like. So in here, again, you can see, so bear in mind this model is fitted on your, you can see it as a hard data set here, and this is what you actually observed. And then you can project both the standard error and your expected return over this time period. And here, the good thing is you can get the p-value, so then you can say, how unlucky am I here? Because you can imagine if this curve were to fall here, it's like, well, A, this model doesn't capture it, B, well, given this model seems to capture this part fine, something is screwed up. But if your p-value returns you something like, I don't know, say 35% p-value and so on, you can be like, well, I guess we are a bit unlucky, and also our performance does decay over time. This is a thing we need to fight against. This is just something we need to, fight by bringing higher edge models, higher performance models. And again, so this sort of thing, if you started doing that on day one, when you see this problem, you're going to make your life easier because you're going to say, well, if we are a bit unlucky, then that's just the way it is. You realize the magnitude of the problem, and then to say how much attention do I need to give to these individual sub-problems. So then here is like lesson thinking before committing. Before commissioning work, have you tried to understand the scope of the problem? What's the easiest experiment you can do to diagnose a problem? That takes 1 hour. These each individually takes a day, minimum, a day, 2 days. So first understand at a high level what the problem is, then go into details with how exactly you want to diagnose each individual sub-problems. So case study 3. Knowing this is the case, so let's see. So, our model performance is decaying over time, and realistically, the only thing you can do was like, let's roll out better models. Let's improve our model performance. So you have a month's time. We stumbled 2 great papers. Maybe some people here already heard about the paper. So one from Yandex, Neuro-Oblivious Decision Ensemble. Sounds fancy already, It sounds like a fantastic model. Got TabNet from Google. Attentive interpretable tabular learning. These are novel models from big groups. And they are specific to our data set, tabular, time series. Okay, cool. So let's try them. They've all reported on, in each paper during their ablation studies and so on, they all report their evaluation on certain benchmark data sets, and we see, okay, everything checks out. You implement these things because normally what you do is you chuck the existing GitHub code, try it on your data. It's not that performant, and you're like, okay, let's try to tweak something about the architecture, and that requires you to have a deep understanding about the architectures. So you really try to understand the paper, and you look at the code. Sometimes, so these research code are not to our standard in terms of productionizable. So then we end up re-implementing some of them, copy-pasting some, refactoring some, so to our code standard that we really understand, tweak specific architectures to suit our needs. So this is a month. This is 1 month work. So this is me. I was in charge of the node, the top paper, and another guy was in charge of the bottom paper, and we were going in parallel. This is 1 month work, tweaking everything. And it didn't work. It performed completely garbagely. We axed the whole project. A year later, this paper came out. Tabular data, deep learning is not all you need. One thing it says, we show that in most cases, and this paper specifically addressed the 2 papers above, each model performs best on the data sets used in its prospective paper, but significantly worse on other data sets. So these are big group researchers. This is my frustration with the research field currently, which is big groups are cherry-picking the data set of which they're reporting to the archive. And no reviewer is going to do that level of work to say, well, you said, you've got like this 8 data sets, they all outperform XGBoost, like GBM or whatever. You know what, I'm going to do it on 25 data sets just to verify. No one's going to do that kind of work. And then, well, turned out, there's this one guy, this is just a paper on the archive. I don't think this is published anywhere. And say, well, they were overfitted, they were cherry-picked on these very specific data sets. So what we were seeing were expected. And that sucks. That's like, whole month of work just wasted. So for us, the lesson is do the simplest thing. Be extremely wary of shiny objects. Any of these stuff for us is shiny object in a sense that it's untested on the real-world data set. No other people say they concretely work. We are going to try them, but that's our 20% of the time. The 80% should be on what's simple to implement. What are the things that you can do that you can get the evaluation straight away? What are the things that's not garbage out of the box? In fact, I personally, so this is like just personal preference, I personally have a rule of if it's garbage out of the box, it's garbage, basically. If it's reasonable out of the box, then you can spend time on it. That's just a personal preference. So action to improve model performance ask, what's the simplest thing I can do right now? And the simplest normally, you can talk to Hamish. Hamish improved the model performance, I think one market by 15-10% PL, 3-4 lines of code. That's all. I've seen complex model architectures achieving the same amount of performance with 300, 400 lines of code versus 3 lines. So you can measure your return on line of code investment there. If something could take days to implement, it has low expected value. That's just the way it is. Cool, that's basically it. So as discussed, all the data you saw was actually synthetic. You can check the code there. And that's not made up. That's not made up. That's a company return at certain time period to certain amount, obviously. So we are not actually setting money on fire. And currently we are hiring quant developers, traders, people specifically in the execution team. We're very flexible with the hiring process in a sense that we are a very small team, as you can see. So people should be able to almost handle everything, every job, every role. I've been spending the past 6 months almost working exclusively in hiring. And that does add value to the company, and that's basically how the company operates. It's like what adds most value, and let's do that. What's a person actually good at a certain job, and then let's do that. Would you rather do something that you're really, really good at, or would you rather do something that you're interested but not good at it? These are the sort of like our hiring ethos. So yeah, shoot us an email at hiring@seamlessml.com, and I'll open the floor up for questions. I have no questions. I'm also happy with no questions. Sure.
You mentioned something about automated checks for data leakage.
Yes.
Could you go into any more detail about how you do that?
Sure, of course. One simple way would be you can ping your data provider, right? You can ping your data provider. So today, this is your actual trading day. This is your live ping. Ping your data provider about today's data set and so on. In a week's time, in a day's time, you can ping your data provider with the yesterday's data set. Did the value change? If the value changed at all, you should be like, why? You should call the data provider up. Why did you change it? That's weird. And sometimes it's for good reason. Sometimes we'll be like, well, we made a mistake in our live data providing. I'm sorry. Or sometimes really, really dodgy answers. So these are the sort of things you can check. It's a very simple assertion, right? Ping it twice and then assert. So that's one way to check.
So I was interested in your case study 3. How often do you find models and things from the literature and it's actually useful? Because I've read a lot of papers before about similar sports like football, and they will report models, and the reason that they report them is because they don't really work very well. If they worked well, then they wouldn't report them.
Correct.
So how often do you find these kinds of literature reports to be useful for your work?
Extremely rarely, but you can get the idea from a paper. So we do read papers for the underlying ideas. Classic papers work really well. Give you an example, ResNet works really well. the very classic, like we won't survive without like XGBoost, for example. That's the classic paper, works really well. So you've now got a choice, right? Do you read classics? And everyone should read classics. But then you have the new paper. Do you read them? Do you not read them? And I think everyone should read them. But A, be skeptical. And B is you want to say what's the underlying idea behind this paper. Is there anything I can tweak it specific to my data set? I basically read paper for idea generation, not for copy-paste code on GitHub. Yeah, yes?
How much, like, as a company, do you invest into looking into like alternative data sources, for example, like news headlines or something which is more difficult to process in a automated setting?
So that goes back into doing the simplest thing. So we would, once a quarter or something, we'd come together, be like, let's buy some data set. And then you rank them by what you think could be profitable and the ease of processing. So you figure out this rank, and then you do it almost algorithmically from there, and you select the best. And we hardly ever select the news stuff because, again, you need to think about how you are going to do it in practice. So are you able to have news data all the way to 2000? If not, then you have a problem because your model needs to be trained from year 2000.
Arguably, you might have like the most predictive power because someone says my horse is ill. That has huge.
Yes, but then that's covered in the veterinary record. So then you think of like what's the simplest form basically of that underlying data.
Yeah, I got a question about, all the three cases, they are just about like one strategy. So I guess you guys will implement something like portfolio optimization. So if one strategy is really good, if you run some algorithm on like portfolio optimization, it will allocate lots of money on that best strategy whatsoever. So is there any lesson or failure that you learn from like portfolio optimization that you can share with us?
Unfortunately, I'm not the best person to speak to for this part. That's actually the only part I'm not doing currently. Well, ish. No, actually, no. I don't do the exact execution part. So I'm not sure how that's it.
I'm wondering how important is like domain knowledge in algorithmic trading? Zero.
Zero importance.
Hamish has never seen a horse.
Exactly. I've never watched a horse race. Well, I've watched one. Yeah.
In terms of feature engineering, do you not need to take into account like if this feature is just not important?
You do it algorithmically. You develop tools to test the significance of a feature and so on. And then there are many ways to make features. You can think of, and this is why we have people of different type of, say from creativity scale or to just we try to have orthogonal people. Some people have completely different ways of writing a feature. I've seen a guy who came in and bought like 20 horse racing books and would like just highlight them line by line, be like, oh, that's a feature, and then just go on and code up all the features. That's fine. I've got people who sort of like, Charles' example, sort of like they said like, okay, it's a rolling mean of this thing. This is it. Like I'm gonna do this 10 times. That's also fine. Many ways.
Okay, thank you.
There are so many underlyings for investing. Why do you choose horse racing for the underlying? Why do you choose?
That's a good question. It depends on the size of the company. So, for example, if you guys will do it right now, if you guys will, and I can encourage people, like if you're interested in this, start doing it yourself. Always give me a call. Be like, we will always have for people to try trade themselves. It's like try Bitcoin or something. Try crypto. Try to trade crypto. It's like at certain times you select your asset given your size. You can't trade less equity, for example, like the treasury bond or something like less high setup cost or whatever. And we're not really defined by the asset class. It's just currently like we traded horse racing 3-4 years ago. We've done really well at that in the UK. Let's do that extremely well in Hong Kong, and then we choose our next asset class. It's also very liquid. I'll give you greyhounds racing is an example where I'm certain you can get loads of edge in that, but the volume is not high enough in the sense that if you tell your manager like, yeah, I've got this model that churns out like 100 pounds extra per day, and then any more I'm the market basically, and then it's not going to be of interest to a systematic.
How do you split up your efforts between trying to get new data and working on better models? Like, you have a data set, at what point you decide that I've done all I can with this data set? Like, this is the best performance I'm going to get with this data.
That's a good question. It's a bit hard. What you can do is you can track the progression for model improvement given a specific data set. And that's something we actually should do more of. We don't do that enough. And currently it's like a feeling of like, oh, it's been really hard to get model performance increase and so on. If I had a magic wand, that's what I would do. Like going back in time, I would say let's track the progress of the model performance evolution. And when you see this significant plateau or something, it's time.
I noticed that you have different roles, like software developers, quant researchers. Is there like a qualification for, like preferences for different qualifications for different roles? Thank you.
No, it's so I'll just elaborate that a bit. It's you want to do things that you're most suitable at, but that you don't know and we don't know. Because you know yourself really well, sure, but you don't know the industry that well. We know the industry quite well, but we don't know what you're like. So then it's almost like a trial and error, basically. So someone gets on board with us. The optimum way would be like, let's try at the same time, 3 roles at the same time. See, but that's not how reality works. But the idea is, people can specialize and transition as they, go through the process.
And what qualities are you looking for in the next hire?
Practical and driven. No, sorry, the other way around. So driven and practical. Yeah. That's it. It's like, how much do you want this? Like, how much do you want the graph going from here to there? That's literally it. Yeah. Cool. Shall we end it here? And basically, there's more pizza here. There's more drinks. I'm definitely getting drunk. So yeah, our employees are there, and then we'll open the room up basically. Thanks so much.